is a golden rule which says, always be aware of prevailing conditions before taking expensive measures. In this instruction film, we will show how the so-called Bresle method functions when assessing the density of salts on surfaces intended for painting or other kinds of treatment. Cleanliness is absolutely crucial for the quality and service life of surface protection of bridges, ships, offshore rigs, buildings and steel constructions in general. Enormous savings can be achieved by checking the surface cleanliness when carrying out maintenance painting, which is why the Bresle method is a vital aid in economizing. Salts, first and foremost chlorides and sulfates, have an extremely negative effect on surface protection. This is due to the salts causing what is known as osmotic blistering, which means that the salt draws in water through the layers of paint. No paint is absolutely waterproof. Gradually, the blisters enlarge and the paint begins to flake and corrosion sets in. Even when carrying out inspection after fire or water damage, it is important that checks are made regarding the density of surface salt in order to know what action is needed. PVC, a material often used in the building industry, produces, when burnt, hydrochloric acid. The hydrochloric acid then settles on surfaces and considerably accelerates the rusting process. If a decision is made on the condition of the surface before any painting begins, it is easier for the purchaser, paint supplier and contractor to reach an agreement. The Bresle method simplifies measurements easily and economically. The Bresle method consists of an ingenious patch of plastic and rubber approximately 5 centimeters square. The patch is attached to a suitable region of the surface intended for painting. Distilled or deionized water is injected through the patch in order to extract the salt. The conductivity must be measured both before and after taking the sample, which will show how much water-soluble salt is on the surface. Thus, the conductivity in the solution from the sample tells us how much water-soluble salt is on the surface. The result of the assessment determines whether it will be possible to paint immediately or if the surface needs cleaning first. The Bresle method of testing meets the demands of the international standard ISO 8502-6. The testing technique, combined with the evaluation of the conductivity, as this film shows, also follows the standards required for ISO 8502-9. The Bresle method equipment consists of a handy analysis case containing a conductivity meter with measuring probe, distilled deionized water, graduated measuring tube, Bresle patches, syringe, injection needle, square magnetic plate and a textile brush. The equipment can be supplied by the SP, the Swedish National Testing and Research Institute, or one of our retailers. This is how the simple procedure is carried out. Begin by choosing a suitable place on the surface in which to carry out the test for the density of salt. The area chosen should preferably be dry and free of any loose rust particles in order to provide satisfactory adhesion of the patch. Remove the outer protective paper and the square of punch-out material with its inner protective paper. Press the adhesive side of the patch against the test surface with the latex strengthening on the outside. Sometimes the test area needs to be cleared of flaking rust, in which case do the following. Cover the test area with a magnetic plate just where you intend to place the patch. Clean the area surrounding the magnetic plate with a textile brush included in your equipment. Then remove the magnetic frame and firmly press the patch onto the cleaned area. Before performing the test, the initial value of the water's conductivity is measured against the zero reference value. Remove the graduated measuring tube from the measuring probe and pour in 15 milliliters of distilled or deionized water. Then, using the syringe, draw in the water from the graduated measuring tube. The syringe should be full. Then eject the water from the syringe back into the measuring tube and remove the syringe. Then insert the measuring probe into the graduated measuring tube and move gently up and down. Set the conductivity meter to a suitable range, usually around 0 to 200 microsiemens, and note the reading. This is the zero reference value of the water conductivity. If the zero reference value exceeds 5 microsiemens, the equipment has probably been polluted during earlier use. Repeat the whole washing procedure. If this fails to reduce the zero reference to less than 5 microsiemens, replace with fresh distilled water. Now we are ready to inject the water into the fixed patch. Draw 3 milliliters of water into the syringe from the graduated measuring tube. Insert the needle into the frame of the patch and inject the liquid. Make sure you do not insert the needle into the membrane of the patch. Do not remove the syringe, but use it as a pump and pump the water in the syringe and the patch compartment for approximately 5 minutes, using 2 to 4 pumping strokes per minute. When this operation is completed, suck the entire volume of liquid back into the syringe and eject it back into the graduated measuring tube. Then insert the needle probe. Connect the conductivity meter and assess the conductivity of the liquid. Make a note of the reading. Then calculate the surface density of the water-soluble salt in milligrams per square meter of sodium chloride in the following way. Subtract the zero reference value, L0, from the last measured value, L1, and multiply the difference by 6. The reference value should be below the specified or recommended by the paint manufacturer or purchaser. An example of a guideline regarding reference value limits is the Norwegian recommendations for offshore rigs, where the value should not exceed 20 milligrams of sodium chloride per square meter. After a fire in the electronics, the limit should not exceed 10 micrograms of chloride per square centimeter on the surface. Any higher density requires immediate measures. In order to retain complete reliability of the measuring equipment, always take great care in disposing used liquid and cleaning all parts thoroughly after use. With the help of the Bresle method, you have now determined the density of surface water-soluble salts. If the value meets the requirement levels, you have made an important step in assuring quality. The Bresle method provides a quick and easy control, as well as being a small investment of great worth. The Bresle method is an obvious aid in carrying out quality work. Order the equipment from us at SP direct or from one of our retailers. SP, the Swedish National Testing and Research Institute, has the largest and most qualified resources for technological evaluation, measuring techniques and certification, research and development.